Hi there, my name is Peter Marinelli. I'm a graduating manufacturing engineer, and my senior project is called the Interchangeable Backpack Designed for Manufacturability. And my technical advisor for this project is Dr. Dan Waldorf. On the agenda today, I'm going to be talking a little bit about the background of this project, my problem statement, my objectives for this project, my design, the prototype I made based off of the design, the manufacturing process I designed based off the prototype, cost analysis for this manufacturing process, followed by the results and the conclusions of my project. So a little bit of background. As a lot of you guys know, a common backpacking backpack is a single bag backpack. It could be either internal or external frame. I discussed this in my previous video from last quarter. But some of the inefficiencies of this single bag backpack system is that when you're trying to bring multiple bags on a trip, it's very, very large when you're trying to store the bag that you're not using, and it's also heavy when it's being used as well as when it's in storage and not being used. So for this project, I came up with a new backpack system, which leads into my problem statement. Backpackers often want to do multiple tasks on a single trip that require different backpack combinations, but they want to carry as little weight as possible and only have a limited volume to store it in. The current backpack options on the market do not provide this ability. So the objectives for this project is to identify the best temporary interface for my backpack system so that it can be interchangeable, reduce the volume and weight of the backpack bag when it's in storage by at least 50%, design a backpack system, create a bill of materials for this backpack system, actually build a prototype for this backpack, then designing manufacturing based off the prototype, and determine what the production cost would be to manufacture this backpack. So some design goals that I kept in consideration throughout this process was creating a backpack that's easy to change so you can easily interchange different bags, make it comfortable for the user, make it lightweight, as well as compresses down really well for storage to accomplish the volume and weight goals, as well as maximizing the use of standard off-the-shelf components so I don't have to make them myself, followed by making it very easy to manufacture so it can be cheap and efficient. For the design process, start out with a lit review, doing some background research on different backpack systems and different ideas. From that, I created some preliminary designs. After those preliminary designs, I did a couple weighted selections for the different types of interfaces as well as different materials to be used. From the results of those, I got using webbing and buckles for the interface and nylon for the backpack material. From those selections, I revised my design. Then from there, I broke up that into different components and subassembly designs. Then actually made the backpack, followed by creating a manufacturing process design and cost analysis for it. So here's a drawing of my back panel design. Fairly similar to a typical backpack. It has the hip straps, the shoulder straps, the load lifters on top to tension the shoulders as well as for the hips. The differences for this backpack system is that it has the 3 female ends of buckles attached to both sides of the back panel. These are the connection points to connect to the actual backpack bag. There's also a big piece of fabric on the bottom that I'm calling a catch, with webbing extensions and buckles on it. This catches the bottom of the bag, and then the webbing extensions go up and over and attach to the top of the bag or the brain top pocket of the backpack system, and that compresses it vertically. So for the backpack bag design itself, it's a fairly simple design, pretty similar to a lot of different backpack bags. It has stretchable side pockets, stretchable front pocket, has a buckle to loosen or tighten the front pocket. It also has a drawstring for the top to open and close the bag, a hydration pack on the inside. But the difference in this backpack bag system is that it has the 3 male end of the buckles with webbing extensions. What this does is this attaches to the backpack back panel, and the webbing extensions can be tightened or loosened to compress or release the backpack bag. For the brain top pocket, also fairly similar to a typical backpack brain. It has a top zipper for the main compartment and a lower zipper, a hidden zipper for small stuff underneath. It has two pieces of webbing that feed through ladder lock buckles on the back panel. This attaches it to the back panel, and then two male parts of the buckle that connect to the female parts that are attached to the catch on the bottom. This is what vertically compresses the backpack bag and keeps it from jumping up and down on your back. Here's a list of the bill of materials for the backpack system, divided between the brain, the backpack bag, and the back panel. Overall, there's about 20 different components used in this system, and it shows you how much of each and what lengths are required and what the waste percentages are for each of them. So for my prototype, here's a series of pictures throughout the prototyping process. Originally it started with the patterns on the top left. It shows you all the different steps from creating the patterns to cutting out the fabric to creating sub-assemblies, sewing together different pieces of fabric for the different components, creating the aluminum frame, followed by the actual end products in the top right for the backpack bag, for the back panel, for the brain, and then the whole system together in the top right. So the prototyping process was an iterative process. Throughout the process, there's a couple different design changes to make it easier to manufacture for myself, as well as on an industrial scale. Also to make it more visually appealing and fit the character of an actual backpacking system. Overall, I feel like the prototype turned out really well. Definitely a good first round, but definitely has a few improvements to make later on. So once I finished my prototype, I had it user tested to give me feedback on my backpack system. For user testing, I gave the volunteers a survey to fill out to use it and try it on and see how they liked it. The survey covered comfort, looks, weight, usability, as well as most and least favorite things that they liked, recommendations for improvement if they'd buy the product, as well as general comments. From this survey, I got a lot of good feedback. A lot of people really like the product. There are also a couple things that can be improved on, one of which is securing the bottom of the backpack from swaying side to side, improving the strength of the seams. A couple of them broke during testing, as well as improving the looks to make it more aesthetically pleasing, having a softer material for the user back panel interface, as well as creating a bottom opening so you can access the bottom of the large backpack. So once I got this user feedback and created my prototype, I designed a manufacturing process. I designed it for low volume, medium volume, and high volume production. Listed there are all the different tools and pieces of equipment that are required for the different levels of production. And then on the right are pictures of the different tools. The two sewing machines on the top right are the two sewing machines that I use for my process for the low volume production of this product. Then for the high volume production, more automated than the previous two, and the pictures on the right show higher end, quicker, more efficient ways of actually producing my backpack system. So going into cost analysis, I broke it up into manufacturing my product between the US and China. From there, I broke it down into low volume, medium, and high volume production, as well as direct material costs, direct labor costs, and indirect production costs. So from this cost analysis showing the United States, if you were to make a low volume backpack, it would cost around $766 per backpack system, and if you were to do a high volume production, it would be about $300 per backpack system. If this were to be sent to China, it would cost around $210 per backpack system for low production, and about $77 per backpack system for high volume production. So for selling cost analysis, my target range to sell this product for is about $200. Comparing it to other similar backpack systems, it fits right in that range. Other backpacks range from $200 to $300, so this is on the lower end of that. So if my selling price target is about $200. Given the numbers at hand right now, that means that it has to be either a medium or high volume production based in China for this to be a potentially profitable product. So overall results from this project, I created a backpack system with a storage volume that reduced by at least 600%. The upper table shows you that the storage volume for my backpack bag is only 96 cubic inches, where if you were to store the other full-size backpack systems, they are far more, from 726 cubic inches to 864 cubic inches, which is 6.5 to 8 times as much volume taken up. As for weight reduction, it was reduced by about 50% or more for those same backpacks. My backpack weighs about, the whole backpack system weighs about 2.42 pounds, where the other backpack systems range between 3.5 to 4.1 pounds. So the reduction is between 47% and 70%. So some improvements for the future when I plan on pursuing this down the road. The bottom catch needs to be enlarged to better hold the backpack system. The different seams and joints need to be strengthened to extend the lifespan of the backpack. There's also a few minor design changes to improve the manufacturability, from tapering the foam inserts for the shoulder and hip straps, design the buckle webbing to be a certain length so it can fit through the machine easier, as well as going from curved to straight edges when you're sewing them together, as well as trying to reduce the number of pieces of fabric to reduce the time behind the sewing machine. Other feedback for improvements are trying to improve the looks so that it can be more aesthetically pleasing, so it could potentially be more marketable, using softer mesh materials for the user interface, as well as making it different sizes for different sized users, and refining the ergonomics of the back panel design. So in conclusion, I feel like this was a really good first prototype. There are areas for improvement, but definitely a good first try, definitely a great senior project. The volume and weight of this backpack system were both reduced by at least 50%. Got a lot of good user feedback, a lot of positive comments, as well as a lot of ways to improve. And for some design changes, it needs to be improved in terms of strength as well as manufacturability. And for costs, it's a fairly expensive part to make. And if this were to be made in the United States, it needs to be less expensive, so it needs to be more manufacturable and easy to make. So that's another thing that can potentially be improved on. Thank you for your time.